Okay, I think it's time we get started. All right. Hello and welcome to today's OSMIND webinar featuring Austin Engineering, who will be giving us a presentation on trays, what matters most. My name is 𝗕𝗿𝗄𝘀𝗁, and I am the OSMIND State Manager for Queensland, and I am delighted to be your host today. Before we begin, I would like to acknowledge that I am hosting this webinar on the traditional lands of the 𝗲𝗂𝘃𝗏 and 𝗕𝗿𝗆𝗃 people, and I also acknowledge traditional custodians of the various lands on which we're all working today, and the Aboriginal and Torres Strait Islander people that may be attending this webinar. Welcome. From Austin Engineering, I am joined today by Brad Higgins, General Manager of Sales for APAC, and 𝗂𝗃𝗀𝗃𝗁 Engineering Manager for Asia Pacific. This webinar today we'll discuss the evolution of tray design and how smarter engineering is delivering real results in payload, wear life, and cost per ton. Discussion will unpack how tray geometry, material selection, and digital innovation are helping sites move more material, reduce maintenance, and improve overall fleet productivity. During Austin's presentation today, you will have an opportunity to submit your questions live. Please do so as your questions come up. There's a Q&A button there at the bottom of your screen. At the end of the team's presentation today, we will get to as many questions as possible in the time allowed. And I should also mention that this webinar is being recorded and will be made available to all attendees. It will also be on OSMIND's YouTube page as well. All right, well, with all that said, I know you all didn't come here to listen to me talk, so I would like to now hand it over to Brad. Brad, the audience is yours.
Yeah, thank you, Tammy, and appreciate the audience's time today. Hopefully we can add some value. This is the third webinar that we've done with Austin in the series, a third and final. And today we're going to be talking about truck bodies. And what goes into the design, as Tammy just mentioned. And leading, I guess, the conversation piece today, our industry expert is 𝗂𝗃𝗀𝗃𝗁, who's our engineering manager here in the Asia Pacific region. 𝗂𝗃𝗀𝗃𝗁 brings over 20 years of experience. He's worked all over the world. He had come from North America prior to working with Austin. And his responsibility with Austin, he oversees a total of 23 engineer and draftees across, I guess, 2 continents and 3 different countries is where his team is spread far and wide. And he's got quite an arsenal of products that he oversees. And 𝗂𝗃𝗀𝗃𝗁, from his self-admission, he's driven with that product development focus. And in the time that he's been here at Austin, he's definitely been very forthcoming in producing and that innovation that Austin is famous for. I guess a little bit about Austin. We have been around for over 50 years. We are, the longest serving and largest non-OEM manufacturer of customized truck bodies. We've done over 15,000 trays manufactured and sent them all over the world. Austin does operate on 4 different continents, and we have 6 different operating facilities where we manufacture and maintain and service our own products, as well as multiple other build partners and the likes all over the world. So I guess we wanted to show this slide because it talks from strength in regards to probably 80% of our product range out there in our manufacturing facilities is focused around the truck bodies, and it really is where we add a lot of value for our end users. And I guess 𝗂𝗃𝗀𝗃𝗁's going to be talking through what we do for our end users and a little bit around that design concept where we can add value for our mining customers. So with that said, 𝗂𝗃𝗀𝗃𝗁, I'll hand it over to you, mate.
Thanks, Brad and Tammy, for the introduction, everyone. I'm talking about this is a decisive factor in final design outcome. I'll start with that. When we talk about designing a mining truck, the first thing that comes is the guide is not the payload, not productivity, but safety. At Austin Engineering, our philosophy is very clear. Safety first. A tray that compromises safety is not an innovation, it's a liability. Now, safety takes many forms. It starts with ensuring structural integrity. It continues with designing for predictable cam life. So the tray does not surprise the operator with failures. It extends to axle load splits, ensure the truck brakes, steerings, and the suspension perform as the OEM intended. The
Sekran, we might have just lost you there, mate. Okay, we'll just wait. I'll just get Tammy. Can you just confirm you lost Sekran as well then? Sorry.
Yep, I sure did. We sure did.
Okay.
You weren't
All
the
right.
only
Well,
one.
I'll jump in. So that's okay. Sekran is calling from overseas at the moment. So hopefully you can, here we go. Sekran, if you leave your camera off, mate, it might give you a better connection if you could continue without your camera. Sekran, if you turn your camera off
Can
for
you
a
all
better
hear me?
connection, we can, mate. If you could turn
Can
your
you?
camera
All
off,
right.
it might give you a better
Yep.
connection.
I'll do that. Yep.
Thank you.
Thanks, Brad. Yep. Now, safety takes many forms. It starts with ensuring structural integrity. It continues with designing for predictable campaign life so that tray does not surprise the operator with failures. It extends to axle load splits, ensuring the truck brakes, steering, and suspension performed as the OEM intended. If the mission will be unsafe on the haul road. Payload optimization is of course critical, but payload cannot come at the expense of tire life, suspension reliability, and also on operator safety. Our job is to design trays that gives mines maximum productivity while staying within the safe operating conditions. Mine-specific conditions also define safety. A tray built for 𝗕𝗏𝗴𝗴𝗏 iron ore will fail quickly in a South American copper mine if it has not been adapted. So altitude, temperature extremes, haul road designs, and fragmentation sizes. These are all the real world conditions that determine whether the design will succeed. And finally, a tray must enhance the host asset, not just ride on it. The right tray improves mission stability, reduces spillage, lowers fuel consumption, and ultimately extends the life of the truck. So the decisive factors are clear: safety, payload, mine conditions, campaign life, structural integrity, and axle compliance. This is the foundation of Austin's design philosophy. Once we know these priorities, the next logical step is to define the design baseline, to create the DNA of the tray that everything else builds upon. Defining the design baseline. Defining the design baseline is like creating a blueprint for the tray's life. It's not just engineering data. It is the context in which the tray will exist. So we begin with the host mission details. It's a make, model, and capacity. Every OEM provides guidance on their axle split loads and the interface details. If you design outside those limits, the entire mission is being compromised. Next comes the site-specific accessories. Each accessories adds weight and changes how the tray performs, so they must be factored into the baseline. Then we move on to the commodity. Coal, iron ore, copper, and gold all demand different wear strategies. The density, fragmentation, and abrasiveness of the commodity define plate thickness, liner type, and discharge angles. A sticky coal mine tray looks nothing like an iron ore tray. We must also consider wear severity. How quickly does the commodity erode structural members? How much impact energy is delivered per load? These are all not trivial details. They dictate the campaign life. And finally, uh, dump and haul road conditions. A tray designed for flat, even haul roads will not survive in a mine with steep ramps and uneven benches. Clearance at the dump site, tipping geometry, and road width, all of this must be captured at the baseline. This baseline becomes the DNA of the design. Without it, an engineering work is guesswork. With it, the tray is built for success, and that's what we do here in Austin. But defining this baseline still isn't enough. We must go deeper into the heart of the problem, the commodity itself. Brad, if you can move on to the next one, because ultimately it's the commodity that shapes the design more than any other factor. Commodity is not just a cargo, it is the driver of every engineering decision what we make here. Let me give you two contrasting examples. Coal is light, or any other ore is just light and a sticky material. It tends to cling on the tray walls, creating carrybacks. This reduces payload efficiency and forces additional fuel burn. We might be designing trays with smooth, flow-friendly surfaces and discharge geometries that prevent the hang-up. Whereas on the other side, there's ores which is sitting on the other hand with dense and high abrasive properties. Every load grinds down the tray flow with tray flow like a sandpaper. These applications demand thicker liners, replaceable wear plates, and material selections that balance the strength with weight. Moving on to the fragmentation, this also matters. So finer material flows like water, while blocky material impacts the flow like hammers. If the fragmentation is large, impact loading is severe, and the tray flow and wells must be reinforced accordingly. Discharge behavior is equally critical. Does the commodity flow cleanly out of the tray, or does it hang up, forcing operators to jerk the tray to clear the load? Poor discharge design is a safety hazard and a productivity loss. And then there is a dump clearance. Trays must be engineered to clear crushers, hoppers, and dump edges without material hang-up. If clearance is wrong, you get blockages, safety incidents, and downtime. So commodity defines everything: impact, wear, discharge, and carryback. Ignore commodity, you ignore the reality. Now let's think what happens when the commodity actually enters the tray. The shovel operator raises the bucket, swings across, and dumps the load. What forces are unleashed in that moment? That is what we will cover next. Loading forces are the true stress test of any tray. When a 70-ton bucket of rock drops from several meters above the floor, the impact energy is immense. That energy must be absorbed and distributed by the tray. If the design is weak, cracks form. If it is strong, the tray continues to perform. Fill factor is another important element. A tray that consistently achieves 90 to 95% fill. Pass matching ensures efficiency. If a shovel needs 6 passes to fill a tray, that could have been filled in 4 cycle times is wasted. Fuel burn increases and productivity drops. Tray size must be engineered to match the site's primary load tool. Now, let's address the reality of overloading. It happens, and that is why we design in line with OEM policies. 10-10-20 overloading policy. The policy is not arbitrary. It protects operators, machines, and mines. The average payload must stay or must stay or below the target payload. Up to 10% of the loads may go up to 110% of the target, but no single load may exceed 120%. Beyond that, you are outside safe design limits and you're compromising the truck's life and the operator's safety. We engineer our trays to handle this distribution. Critical load paths are reinforced. Wells are sequenced to minimize stress, so when an occasional overload occurs, the tray sustains it without catastrophic failures. We've talked more about the forces during the load. Now let's consider the bigger picture, the operating envelope in which the tray must function. Brad, if you may please move. Thank you. The operating envelope is everything that defines where and how the tray can safely work. It begins with machine interface, the frame mounts, hoist geometry, and even the suspension system of the truck needs to be considered. So these connections are non-negotiable. If the interface is wrong, nothing else matters. Dimensions are another constraint. Width, height, and depth must align with mine conditions. A tray that is too wide may not pass through site clearances. Too tall, it may exceed the height restrictions during transport and even during loading. Tip angles are also critical. If the tray does not tip far enough, material hangup occurs. If it tips too far, it creates instability. Designing for the right tipping geometry is essential for safe discharge. Transport restrictions cannot be overlooked as well. Many trays must be shipped in modular form to meet road or sea freight limits. A design consider assembly on site, reducing risk and cost. And then and there, safety features that some clients request. Nose-tail interference prevention ensures the tray does not collide with the operator cabin. Canopy coverage itself is often specified for operator safety and shovel protection. Finally, the axle split compliance once again comes into the play. If the tray geometry causes too much weight to shift forward or backward, it overstresses the tires, suspensions, or brakes. OEM axle load splits must be respected. The operating envelope is not an afterthought. It is a boundary that ensures a tray is not just productive, but safe and legal to operate.
All right, thanks, Sekran. I guess just to summarize kind of everything that Sekran had touched on there as a customized truck body builder, there's a lot that goes into the thought concept of putting together the right tray to allow you to hold more. I guess there's a balancing act for Austin as well between the end user and also the OEM. So as you heard from Sekran there's a lot of thought process that goes into making sure that we interface with the host machine correctly. And there's also a sign-off with those OEMs where we've got a relationship and they sign off with body worksheets and the like to make sure that our customized equipment does in fact match and enhance the host machine. I guess the purpose of this slide here at the end of what Sekran has just spoken about is really understanding those operational parameters. So the machine is one side, but then the other side is, like Sekran mentioned, the loading equipment, the commodity, the site-driven decisions that allow us to go and design the right attachment to enhance your loading and hauling on site. So I guess the main bullet point from this slide is if we understand what your operational challenges are and we have an open and engaged partnership, then 9 times out of 10, we're going to get it very right, and we're going to allow you as the end user to be able to maximize and enhance the productivity of your loading and hauling fleet. Now, the other side of that, and you get a lot of this from customers that typically Austin builds a lineless truck body. We have multiple truck bodies that you'll see soon. But there's always this kind of argument with productivity and payload is a payoff between reliability and longevity? Well, in some cases, in really harsh mining environments where we're seeing that high abrasion rates, as 𝗂𝘃𝘀𝘁𝗏 had mentioned, then yeah, there's some considerations around wear maintenance strategies and being able to sweat that asset even further. But I guess if you look at what's in the middle of the diamond there, you know, that total cost of ownership focus right from the start, understanding the customer wants to haul more, the customer wants to make more money, the customer wants to forget about their truck bodies and ensure that they are safely going to haul dirt for a set period of time. And I guess that's where we come in. And as the heading says, maximizing your productivity and also sweating your assets. So depending on the opportunity at hand, 9 times out of 10, we're able to do that both in giving a payload gain, but also in giving that life expectancy gain. And we have a predetermined kind of fatigue life that we run it through all our FEA and our engineering process here at Austin. And that really is about giving the customer, before they make that purchase, because an asset like a tray can be a large purchase. At the end of the day, it's about really boiling that down and knowing what that total cost of ownership is upfront, and ensuring that that asset does achieve that, I guess, that design life by supporting that in the field. And we'll talk a little bit about how Austin supports our assets in the field later on. Back over to you, 𝗂𝘃𝘀𝘁𝗏.
Thanks, Brad. So we've spoken more about the real actual mine site conditions and pros and cons of that. We need to talk about design considerations based on the real mining practices what we follow here. So mining is not a control lab, as everyone knows. It's the harshest environment an engineered product can ever face. So this is why our design considerations go far beyond the CAD models. Structural integrity comes first. We use advanced FEA tools to identify the stress points, reinforce high load zones, and validate life predictions. Double-sided wells are used in critical areas, avoiding weak points that fail prematurely. Coming to the next point, material utilization is the next step, which we just don't use thicker steel. We use the right steel. Q&T plates balance strength and weight. In some areas, lighter plates reduce dead weight. In others, hardened liners extend wear life. It's about precision, not excess. So plate configuration is equally important. Plates are laid out to distribute stress evenly, reduce sharp transitions, and make replacements easier. This lowers maintenance time and extends the structural life. And well joints, the unsung heroes of the tray performance. A single pour well can bring down the entire tray. We control the well sequencing to minimize the residual stress, and we design wells to flow with stress paths instead of against them. These are not small details. They are the difference between a tray that lasts 20,000 plus hours and the one that fails at 4,000 hours. But sometimes design innovation does more than just improve performance. I'll be talking more about the innovation a bit. I think Brad would be taking over the ranges what we have in our portfolio. Over to you, Brad.
Yeah, thanks, 𝗂𝘃𝘀𝘁𝗏. And I'll go through this slide fairly quickly. This webinar is designed to give, it's an educational piece, not a marketing brochure for Austin's truck body range. Otherwise, we'd be here all day. As you can see, we've got 6 design types on the screen. If I start from the far kind of left, is that Westech kind of square style of truck body that we started out with many moons ago. And they also have that square style of lighter Westech Premier body. So, kind of really big, rigid, solid design bodies The Premier is the lighter high performance version of the Westech body, which gives that payload benefit as well. From there, we're coming across the bottom of the screen to the 𝗔𝗂𝘃𝗀𝗁, and you can see the grey sections there. We've got the replaceable floor style of 𝗔𝗂𝘃𝗁 body, very popular with customers in remote areas that they don't want or they want the benefits of a high performance body, but they want to make sure that the body goes life of asset as well, life of truck. So the 𝗔𝗂𝘃𝗁 is a replaceable floor style truck body that allows the customer both of those stronger body designs with a replaceable floor. The 𝗕𝗿𝗆𝐿D was kind of the first of the curved bodies here in the West Australian mining world, where we had a great run of and a long history of supplying 𝗕𝗿𝗆𝐿D bodies. Again, strength a little lighter than the 𝗔𝗂𝘃𝗁. And then from there it advances around to the top of the screen with the Ultra and the HPT being the latest and greatest. So I guess the purpose of this slide is to say, Austin have been doing this a long time. Depending on that partnership, understanding your operational challenges, we do have a truck body design that meets all of your requirements. So we don't have a kind of one truck body design where we go thicker and thinner in the floor and that's what we put out to the market. We truly do sit down, have a listen and customize the truck body to suit what your operation is and how you want that asset to perform. Okay, one of those is around the floor design, Sekran. So I think this might be your slide here.
Yep, thanks, Brad. Yeah, the flow control body is a story of engineering born from necessity. I think a few years ago, a customer approached us with a problem. The truck had short wheelbases, and when they dumped material, the entire load center of gravity shifted behind the rear axle, lifting the front wheel off the ground. It's a serious safety hazard. Everybody knows that. So our engineers developed a solution by designing angle flows. We ensured the CG stayed forward during discharge, and we even built a scale model to validate the dumping sequence before manufacturing the first body. The result was a patented flow control design. What did we achieve? What did that innovation achieve? It eliminates the material surge during dumping. So the truck does not jerk violently, keeps the front wheel safely onto the ground, reduces the dust emissions, and improves crusher efficiency, extends lift cylinder life, and protects the tray itself. In short, it turned a safety hazard into a competitive advantage. Hundreds of flow control bodies are now in operations across the world. That is the power of engineering innovation, responding directly to the customer challenges. Moving on, I think beyond these kind of flagship innovations, we also focus on a practical solution that keep our trays tougher and easier to maintain. I think this slide talks more about that. Every mine is unique, and our solutions reflect that. The wear management is just not a one-size-fits-all package. We use wear strips and towels in high abrasion zones, targeting the exact areas where the material erosion is most severe. In the middle, you can see the replaceable floor, another innovation. Instead of discarding the entire tray when the floor wears out, we retain the skeletal structures and replace only the worn plates. And of course, this reduces the cost and downtime dramatically. And finally, the tail replacement, it offers the same benefit. Rather than rebuilding the whole tray, we can swap the rear segment quickly. This gets the truck back into operation faster. These are the approaches shows why we say our trays are tough as your job, because they are being built not just to survive mining, but to thrive in it. Over to you, Brad.
Okay, thanks, Sekran. I'm going to talk a little bit around some technology that Austin is working on. So 𝗲𝗃𝘀𝘁𝗶, as you can see there with the circled pods on the bottom of the truck body, was launched at Diggers and Dealers event this year in August. Bit of a soft launch. We do have these out there in the field right now and working for some particular clients. But where that was driven from was around, I guess, Austin have a unique fleet management, I guess, system where you can physically go and do a manual inspection at the moment and record your safety, record your thickness testing into the 𝗲𝗃𝘀𝘁𝗶 platform. And as you can see there by the computer screen at the top, it starts to highlight those kind of high wear areas, or if there is any wear areas in your particular body. And we have had some customers that have been very transparent through partnership in regards to sharing their dig data as well, where you can see on the bottom screen on the iPad there, where it starts to map out and give, I guess, a lot more information back to the customer around the wear patterns versus the tonnage moved. And we're getting pretty accurate in regards to some of the reporting into, strategically working out whether we can make those buckets or bodies lighter to perform better and haul more, or whether we kind of change those plate layouts and configurations to make them last a little longer in the field. So this is an operating system right now that is available to Austin customers, where they can log in, they can see their assets, they can see what Austin have built, they can look at all the manufacturing data reports and manuals and everything else that goes along with an Austin product, spare parts lists and the like, through simply logging into their system and being able to track their assets all the way through life. So this is something that is right now and has been for several years been working. I went through a rebrand just recently, about 12 months ago, to the 𝗲𝗃𝘀𝘁𝗶, where we brought it back in-house and we're able to enhance some of the functions of this system. But if you haven't seen or you'd like to know a little bit more about the 𝗲𝗃𝘀𝘁𝗶 platform for your assets, then please feel free to reach out. It's very easy to install, not only ours, but other attachments out there into the system. Okay, I am going to play this video now. So Lever, if you could press play in a sec. This is an overview on the 𝗲𝗃𝘀𝘁𝗶 pods. So I'll go quiet and I'll let the video play, and then we'll talk a little bit more about the pods. Thanks, Olivia.
𝗲𝗃𝘀𝘁𝘁𝗁 is a proven platform. The 𝗲𝗃𝘀𝘁𝗁 pods gives the insights for our customers to ensure that they're moving away from unscheduled breakdowns of their attachments and that the truck body or the bucket intends exactly as it's designed in operation.
The biggest challenge we saw around reviewing customer wear patterns is the irregular pattern and how often they take captures of wear.
What the pods are going to do is take the human element away. By having data fed from these pods directly into 𝗲𝗃𝘀𝘁𝗁, we eliminate the need for someone to physically go and perform the inspection, improving safety, and gives real-time data decisions for our customers where they can log in and make strategy-based decisions on that asset in real time.
𝗲𝗃𝘀𝘁𝗁 provides the ability for our customers to review one tray, but also do a comparison against another tray at a different site on the same truck.
The tech that drives the 𝗲𝗃𝘀𝘁𝗁 platform and pods have been developed by people that actually understand mining and are at the forefront of loading and hauling. The 𝗲𝗃𝘀𝘁𝗁 pods really are a game changer in regards to live data set. It's going to be safer, more accurate. It's going to give us insights that we've not seen before.
In the end, all our customers want to maximise and save money.
That accurate data is going to allow for real-time planning, not only for our customers, but it's going to allow us as Austin to develop the next truck body that's going to go even further.
The next slide. Press that. Sorry, Olivia, if you're pressing the button. There we go. Okay, so Right now, I guess as the video says, 𝗲𝗂𝘀𝗏 is an existing platform. So as you can see on the screen here, this is a typical login page where you go and look at an asset and you can see the overall health of, in this particular occasion, a 𝗕𝗿𝗆 bucket that's on the screen. So you can see its location. You can check out when it was fitted, what date it was fitted, when the last inspection was, what the thickness recordings were at the time. And it basically gives you an overall health check of that asset. Now, what we're doing is with the pods that are out there at the moment and are proving very, very well in trial, is those pods will have a sensor in them that are doing a live thickness testing recording that it's going to take the need away for someone to physically have to go out the site, hop in the back of a truck body and measure it with a manual thickness testing. So at any time, you'll be able to log into the 𝗲𝗂𝘀𝘀 platform if your asset is fitted with pods, and you'll be able to do a download and be able to see the performance of that tray and what thickness is remaining on the life of that asset. So I'm mindful of time, so I'm going to move along a little quicker to the questions. Again, 𝗲𝗃𝘀𝗁 spoke before around some of the maintenance strategies. I won't go into too much detail, mindful of time, but as you can see here, we do have different kind of levels of wear maintenance strategies that we can help apply to the linerless truck bodies we build, enabling you to sweat that asset even further. So these wear strips are designed to be welded in once and not to be gouged out, reducing half the hot work and that high risk work of gouging out wear plates. Okay, and one case study, you can see the green truck body here. No guesses where it is if you're in here in Western Australia, but this is a case study I wanted to finish on before question time. This is direct from the customer. This is where that partnership, where they really do benefit. So this customer was very transparent, allowed us to come to site, go and have an understanding of what they were actually trying to do with their assets. They wanted to carry more coal. They wanted to be able to park up machines, and we were able to help achieve that. So just by swapping out from the old style of bodies that they had on site, we were able to give a 29% payload increase that was proven. So from 106 tonne up to 137 tonne, all while staying within the operating limits of the machine. So no safety, no kind of machine life jeopardized, which equated to 750,000 tonne per machine per annum that they were able to carry. So there is a potential increase if they were to max the tray out to what the tray can actually haul, which would give a further increase. But this customer here is payload managing with their trays, and they've been able to park up some of their assets, which has given them a significant, benefit in regards to the running costs of their mining operation. And this is just one example of many. We could put a million of these on the screen where when we work closely with the customer and we design that customized attachment, we really can give some realistic loading and hauling benefits for your mining operation. And this is the last slide. So if I was to leave you with, a bit of something to remember from today's presentation. So everything kind of goes hand in hand, and we do take care of both the loading and the hauling with buckets and bodies, as per our previous webinar and today's webinar. But it does come down to partnership. It comes down to understanding exactly what the challenges are at each and every mining operation. As 𝗲𝗃𝘀𝘁𝗁 pointed out, a coal mine is not just a coal mine. They all have their own unique features and benefits. And it really does come down to understanding, the material density, your abrasiveness, your maintenance strategy, your outcome. And if we do get closer to the end user and understand your challenges, then we can give those payload benefits. We can give those total cost of ownership improvements, and we can give you an overall benefit for your mining operation. So I will leave it there, Tammy. I know we've kind of run over time there a little bit, so I'll open it up for questions, and hopefully we added some value today in regards to truck bodies.
Great. Thank you very much, gentlemen, for your great insights on to how tray design can really maximize productivity. As a reminder, as Brad said, submit your questions. You can use the interface below that says Q&A to submit, and there's still time to do so if you do have questions. But I do have some questions I can ask in the meantime. You mentioned safety is a top priority. How do tray designs and policies like the 10-10-20 ensure safe operation?
That's a great question. So safety starts with respecting payload policies. So under OEM's guidelines, 90% of the loads can be carried up to 110% for rated payload, and 10% of loads may reach up to 120%. But no single load should exceed over 120%, right? So our trays are engineered around this principle, the geometry, well sequencing, and reinforcements. These all ensures the structure can sustain these load distributions without compromising the OEM truck's performance, like braking, steering, or the structural integrity, basically. This protects the operator, extends the component life, and keeps the truck operating safely under the real world conditions. Hope that answers the question.
Great. Thank you, 𝗂𝘃. We have some questions from attendees now. So let me ask one for Mike S. Do you use any castings in your equipment or just QT plate?
𝗂𝘃, I can see you went on and off mute there. I'll jump in. Look, so for truck bodies, quench and tempered plate straight up. We have explored some casting in the truck bodies before, but we found that the quench and tempered plate in our current models are working very well. And it's around what we do with the quench and tempered plate and working closely with the end users. We do use a lot of castings in our buckets though. So if you haven't watched the webinar on the buckets, the first one that we did, Mike S, I suggest jump online, have a look at the previous OSMINE. There's a lot of castings that go into our buckets. So that may help answer your question.
Great. Thank you. All right, Stu would like to know, can 𝗲𝗃𝗀𝗁 measurement pods be installed on non-Austin bodies?
Yes, Stu. Yes, 100%. They can be added to any truck body. So where they really benefit is truck bodies without liners, which kind of limits the competitors out there that are doing a linerless style truck body. But yes, the answer is they can be fitted to any other truck body out there on the market. Currently, at this stage, there's a lot of pods to roll out on our existing customers, and we're working closely with those partners. That's one of the things about partnering with Austin, but please feel free to reach out, and we're happy to have a look at what assets you've got and where you may want to stick them for future installation.
Great, thank you. And Lynn would like some clarification on whether or not you can provide dynamic payload data.
Not at this stage, Lynn B. So we can give you, it might pay to answer that one offline and give you a rundown with our engineering team about how we do work out our payload. But no, not at this stage. Watch this space with the 𝗲𝗃𝗀𝗁 pods. But no, not at this stage.
Great. Beatrice would like to know, do your trays incorporate any features or sensors that provide data regarding wear or material degradation?
Yep, yeah, 100%. Go and have a look at what 𝗲𝗃𝗀𝘀. So the first stage of 𝗲𝗃𝗀𝗀 is around the wear of the actual tray itself, but the pod is going to unlock some other enhancements. So those customers that jump on early, I guess phase one of the 𝗲𝗃𝗀𝗀 pod is around the thickness and the life of the asset. But watch this space. There's a development team in the background they'll be able to provide. So yes, it does provide a wear thickness of the abrasiveness and the remaining thickness of the floor on those assets.
Great. Let's do one more question. We had a follow-up here. As miners would like to build an overarching view of maintenance planning, is OST-IQ data ready to be integrated with other systems?
Okay, so integration with other systems, I think, is going to be a little tricky right now as we roll out. In future, maybe, but Lynn, maybe reach out directly, and I'll happily get John to step you through what OST-IQ does. It might help because there's some pretty good, I guess, planning tools already built into the system, especially around the buckets. The buckets have been in the system with OST-IQ for some time. The truck bodies and the pods are, I guess, a little more of a recent addition. But yeah, please reach out directly, and I'll happily make an introduction to John that heads up our development team and talk you through the OST-IQ platform.
All right, fantastic. Well, I'm afraid that's all the time for questions that we have today. If we did not get to your question, rest assured that the team at Austin will receive it and can reach out directly to answer it for you. I'd like to give a big thank you to Brad and Sekran and the entire Austin team for taking the time to share your insights with us today. And again, as a reminder, this webinar has been recorded. You will receive a link to that recording, and it's also available or will be available on OstMine's YouTube channel. So thank you everyone for attending, and I look forward to welcoming you to another OstMine webinar in the future. And I hope that you all go out and enjoy the rest of your day. Thank you.
Thank you very much, Tammy.
Thank you, everyone.